Okay, guys, so welcome to the very first video of the series Data Structure and Algorithms, the way I want it. So, the very first thing which we're gonna touch is logic instead of going to, asymptotic analysis or any other stuff that people usually go, because the reason is that there are some part of the links which we're gonna see or gonna touch when we'll be studying data structures and algorithms all together. So let's hop into the video and let's see that what are those links which I'm being like really concerned about. So the very first thing here is a logic, and you'll be like, yeah, what do you mean by like logic is simply like anyone can understand, but here in conceptual mathematics or here in discrete part where you know they have theorized everything with the theory is the most important thing, then we eventually try to solve it in a very specific standard way. So logic is a kind of statement. I mean, it's sort of a statement where the sense could be taken out like really quickly. There is no such thing like that. It depends on person's intuition, mood, motive. The sentence itself is kind of making sense that this can either be true or false. So that's what a logic and a very very at the very bottom of the statement is going to be, and that what defines the logic is. So the example could be, if you look the screen right now, the New Delhi is the capital of Indian Republic, which is true by the way. Then there is one plus one equals two. I mean, there's a like nearly a 300-page book. I should have like put a near about sign like a tilde, but it's like a it's the very same thing which we are studying right now is the logic and proof. So this book is kind of like a step establishes a standard that how we're gonna like deal with logic and proof, how we're gonna deal with mathematics, how we're gonna do things in mathematics. So if you look at the very next example is the Jang, which is my like who's my friend, like is what was born in Manipur, and it's just truth. It cannot be changed. Like it can either be true or false, but like here's the truth. So the examples of invalid propositions, I mean, you can say statements also, like there is nothing difference in propositions and statements. It could be like do this, but the other person like if the other person be like me, like maybe no, I'm not gonna do it. Stand up, maybe like no, I'm not in the mood. Is the sun hot? Like that's a like where it's a little different example right here. Kind of felt like, why is it there? Like it could like can't it be a proposition, a valid proposition? Well, the answer could be no, because like to it depends on a person to person. Like some people might find sun like really hot on a day, and some people not. And also uh, with current technology, I think we could not touch and like land on the sun surface, so we couldn't even know exactly like whether that hot it is or not, or maybe the convection of the radiations, the convection radiations are like hot. So yeah, that's the thing. So okay, we got our statements, we got our like very basic statements, and I think and the logic is like a thing, how could I tell? It's just a conceptualization, or maybe you say the argumentation of a problem statement. Here, what we do is that we kind of stabilize this more and more statement. We kind of refine our problem statement, or whatever the given problem we have, we kind of refine it to a level that we can start solving it in a very, suboptimal, kind of optimal way, but like dividing those problem in a lot of chunks so that we can work upon it like quite effectively and optimally. So that is the challenge which we are solving. But like see, you cannot like solve anything with just one statement. Like you need a complexity of that, like multiple level of statement. So that's where like we're gonna start doing it, the complexities things, with the help of an operator, and that operator is quite simple, and that is a negation. Okay, so negation is here, and you'll be like, hey, like from where this came from. So let me put an example. Like for instance, take that you have your friend, and you might be it might be like that your friend might be feeling quite low on it, like on a very particular day, he or she might come to you like, you know what, I'm feeling like really low, tired, or maybe depressed. Like if it's a case a little bit, a little bit far, kind of common into this generation. So if he or she is feeling like quite low, depressed kind of thing, and so your response is always gonna be like, nah, you're not. I mean, it's just you're thinking. So you kind of negate it immediately. Or maybe your friend came to you and just says that I today I talked to my crush, and like I just talked, and it's like, wait, like no way, you couldn't have, like you could have done something like that. So that's the very beginning of starting a complexity. Like how we are getting, like, so as soon as you kind of negate the very thing, the very statement, what happens that you two, three, or maybe four, it depends, kind of started engaging more and more kind of more and more kind of statement thing. I mean, you started talking to a lot of things, you kind of making more and more complex statements, your talks getting complex, so that eventually it becomes more enjoyable, kind of thing, which is happening right here. There's nothing difference here. So for example, so if you take the proposition P, and why P, where it came from. Yes, see, in maths there's a one big thing, that everything is a variable. We generally do not deal with language. We kind of deal with the language of math, and which is variable, or operators, symbols. We don't deal it with in written language. That's a maths. That's what math is. So here what we are also doing, it's we kind of converting all these statements to kind of variables. And these variables are generally like, there, it's not a standard, it's not a rule, but it's kind of stabilized by the community with people, like over a period of time, like since they have worked together, kind of what happens is they're alongside while working with someone, you kind of started having some sort of standard way. So here in this logic and proposition and all this thing, what we do, we kind of represent it with PQRST up till XYZ. Like it's up, like it's up to you, you can take any variable what you want, but kind of standard is that we started with PQRST. And then where this is gonna be useful, because you see, it gonna help us to reduce the amount of work we gonna, like we don't want to write like a lot of statements, so we kind of convert it into variables, and that's a very good approach. So let's look at the screen, and let's try to understand the example. So let's take the very first statement. Is It's the same statement, there is no two statements, like it's the same statement, there is nothing difference. The thing is that this thing, so instead of writing the not, like this is actually a not operator or negation, it's a not. Okay, so not symbol is represented by like this, like half a tilde, like this thing which is going up there, like a gamma symbol, which is also in maths, but like it's kind of like that. So P, if you take the very first statement, like Chang is a good PC gamer, which he is, but for not me. So the negation of the very first statement is going to be Chang is not a good PC gamer, and which also makes sense because it's just a negation. So like for me, like it does make sense. Maybe not for you. You be like, oh no, like so if you look that P and negation P right here. So maybe for you guys, the very first thing is true. So if for you the first thing is true, then next thing is gonna be false for you. But for me, the first thing is false. Zheng is not a good PC gamer for me, for my perspective. So the second, it's a very same statement, but the negation of that statement is true for me. Okay, so that's what it is doing. High voltage, low voltage kind of thing. Converting high voltage to low voltage, and low voltage to high voltage. Kind of switch. You have your home with table fans, ceiling fans, electric bulb, whatever. Like they're a switch. They kind of just like switch. Okay, then since we started having complexities around that, we just kind of we just cannot work with just negation. We need more, we need something more. So if you look at closely in the language, and the very language is English right here, you can see that we kind of have two kind of operators which kind of help us to connect two statements or propositions, and those are and or. So and operator and or operator is actually being again, like it's maths, so again operator. So again they have been represented by this up arrow and down arrow. It's really simple. So if there is anywhere like an up arrow is present like this in this table right now, here, like, sorry, that's an up arrow. That is also called as conjunction, and the or operator is called as disjunction. Conjunction means, see, if you look at the meaning of conjunction, is that joining of where two or three things are, coming together into one, or maybe, yeah, one. So conjunction is means connecting all those things, and disjunction is disconnecting those junctions kind of thing. Okay, so they're disconnected junctions, they're connected junctions. So but here's a catch. In English, the or operator, the or word, the or connectivity, or the or connector has kind of two senses. What do you mean by that? Or what I mean by that is kind of, there's a thing in English like, if there is an or, you can have like both statements together, or maybe one. It just doesn't care. So that could be your inclusive or. We'll see. And for truth table, like, here is an exclusive or. So what does that mean here is only one, like they need only one condition, not two. So a lot of time what happens is that if you're taking some course, and they kind of have this precondition that only one of these needs to be fulfilled, not two, not none, but one of these, like in those cases, like that is kind of like that has been seen altogether. In conjunction, like it's really simple. So if you said like, I'm gonna study, and you studied, so that's true, like you did study. Or if I study, I'm gonna pass, and you passed the exam, it's like, yeah, you studied. Here is that if I study but you fail the exam, it doesn't even matter, like you failed it. If you didn't study it, and if you pass the exam, that's just, no, sorry, like that's not a good example for that. Oh well, why I'm taking my own examples right here. Okay, it could be like, let's see. You said that it's not raining outside, but it is raining outside. So it's wrong that you said whatever you said, like it is raining outside. So that's false, because you said it, but it's not raining outside. Okay, and like, false is false, false is false. Should I be giving an example for that? Hmm. I don't think, like, I think you get it. Like, if something is already false and other thing is also false, so that's false. Like, what are we gonna do? And is like conjunction, like those things are coming together. It's like a multiplication thing, kind of multiplication thing. So here is their disjunction, like inclusive or, like, quite simple. Anyone is true, like it's true. You can, you can take this very series of data structure algorithm, the very series which you're watching. Like, is there any precondition? Like, no, maybe if you know, that's okay. If you don't know anything, like that's also fine. So it's gonna true. So that's a very quick example right here. I already like given this one, like, there's like precondition for a course, like in your college, like these prerequisites course needs to be fulfilled, any one of them, only one of them needs to be fulfilled, not both, not like two. So these kind of come in handy in your day-to-day life. But you're gonna ask like, hey, you're gonna ask me that, okay, so you told us that uh these things are here, like these statements are here, these methods are here, and is here, or is here, exclusive or is here. Oh, we're gonna see, like, what's the use. So they're practical, like these are theoretical concepts, and here we are like stabilizing the theory in a way, we are conceptualizing, so that we can refine our problem statement very well, and we can create more and more complexity so that we can solve it. So where this thing is gonna come into play is your own very hardware architecture right in your hand. Your device, whichever device you're having, maybe a laptop, maybe a mobile phone, whichever the device you're having it right now, it's like sitting right now in your, in your hardware architecture. So that's kind of thing which is really important when we are computing some sort of anything. So you tap a button, these things are gonna be responsible for that. And the thing that is, and the thing which is called like its practical application is called logic gates, and these are, are a part of the transistors, the very well. We'll see that in a little further in other videos, upcoming videos. So this is where they are, this is exactly where they are. So no one has ever taught me that where the AND gate came from, where the OR gate came from, where the XOR, all this. I like just draw these boxes and just start, kind of, make out the sense of it. So I was like, yeah, okay. So this is where these things are gonna be like useful. This is where they play their role. So what happens in computer is that you kind of create these complex structures of these circuits, these very AND and OR gates, and you kind of, started complexities in a way. It kind of gives you an output. It kind of being able to, solve a really complex problem, because you cannot go with just one NOT gate. You cannot go with negation only of a statement. These statements kind of play out in a way, so these are like binary, like 1 0 and 1 0. So these things kind of work. We'll see in a little further, like in upcoming videos. So that's how it is working in your, data structure algorithm in your machine. Got it? So now, after having these thing AND and OR and XOR, what they like the early mathematicians have also done is that they kind of created more and more complexities, because let me drink the water. So for them, and OR are not sufficient, we need more. So in language, you see, like you look at your mother, like she be like, if you study this and show me the homework completed, then you can do anything you want, or maybe you can play outside. It's not that really harsh condition, but she be like, she wants that. Okay, so that's what conditional statement is. Okay, if you look at the examples here, like if you have studied hard, or what say, you said something which is true and it comes out to be true, like that's true. But okay, so let me give an example right here, the second one. It's saying that true implies false is false. Okay, so okay, so there was this if I see, like there is this marriage of my sister, and I, kind of practiced dance for the very first time in my life. I never had danced ever in my life, so I practiced it, and I couldn't perform. So the thing is that I practice it, it's kind of true, it is true. And the thing is, I didn't perform it where I supposed to be performing, but I didn't. I just uh, it just didn't work out. So uh, there is no meaning of it. So it's false. Like it doesn't even matter to anyone, because even if you practice, if you have done anything, if you have done everything, if you have done, but the result is zero, everything is gonna zero. Like no one really cares about it. So uh, that's the thing. So that's a very example of the second one is you see, if you said something false, you be like, um maybe I'm gonna pass this exam without studying, or maybe anything like that. But you have studied. Maybe you just said false, or maybe you just said somehow, just a random thought. You said like, oh, the coin is gonna fall into the box. Maybe they're like, why I'm coming up with this example, man? Like I don't know. Or maybe you be like, huh. Like you can take like, oh, I'm like losing examples. Like how? Okay, you can take that. You can take that example. Okay, you went to a fishing, and you just throw your fishing cord, and it just went to the water. You just said like, I'm gonna call a like really big fish. It was just a random one, but it comes out to be true, and you didn't even put any sort of food larva or any insect to it. But I don't know, just the fish just caught the string, and you just pull it out. It turns out to be like really big. And or maybe you just said like, I'm a really good fisher, like I can catch any fish I want, and I always catch the biggest fish, and the biggest fish just stuck into your cord in the hook. And so it turns out to be true, and your friends are gonna be like, oh, okay, so he's a really good fisher. Okay, last one is a false true. Okay, so you be like, hey, oh, what is this thing? Like if something is false and its dependency is also being false, then why it's true? Okay, you said something false and it turns out to be false. Okay, and it just turns out to be false. That means that it was true. Okay, that's it. You don't have to like put like too much of a brain here. But that like these are really simple day-to-day life statements, day-to-day life experiences. Just that's it. So with conditional statements, what they also did is they kind of created more complexity. They just started playing with it. So for example, like look at converts. What is this? Like if you take the example, if it is raining, let it be P, and then the streets are wet, let it be Q. So converts be like, if streets are wet, then it is raining, which doesn't even change any sense out of this proposition. Like this proposition remain the same. Contrapositive on the other hand, and if you like don't go with contrapositive, you can go with inverse. And like if you look at inverse, like there's a simple, if it is not raining then the streets are not wet, like really simple. Contrapositive is just like rotating these two together. So it's be like, if the streets are not wet then it's not raining. He simply just put some knots here, like negating the very statements here. Like so these are like really simple thing. See, our main point was here is to get few concepts together. Other is this precedence table, we'll see. So but before that, let's look at the biconditional statement. What biconditional statement is: in biconditional statement, the dependency depends on the both statements, and it's kind of like P and Q kind of, or maybe P depends on Q. P, it's like a the previous conditional statement. P depends implies Q, P implies Q, and operator, and Q implies P. So the example is again like really fun one, like really common. We all have like experienced this. I will be allowed to play video games if and only if, that's really important. If and only if. It's just not only if or if. It's if and only if I finish my homework. It's like really strict. Okay? That's really strict. That's it. That's what biconditional is. So one of the big problem arises is in maths is like really cover, like since you have converted all these statements into variables, and now you be like you got stuck with these variables, these operators. What are you gonna do? Like if there is like really long queue of these variables and operators, how and where do you gonna start with? Where you gonna start? So instead of getting stuck into too much into it, what we did here is a little clever thing. We kind of created precedence of these operators. So in language also, in programming languages also, they kind of have precedence table of operators. So it kind of depends from where it start gonna read, from left to right or maybe from right to left. Think of this as a statement, very statement, like think of this statement. So if it founds a negation operators, that will be resolved at the first time. That's how it is going to work. That's what this precedence table is. It's really useful in creating the precedence for the operators in programming languages, which we'll see a little later. Now coming to the next part is the predicates and quantifier. Oh god. Okay, predicates are like, okay, so so there are like a little concepts also coming for our next video. Predicate kind of describes the property of an element in a set. And what is a set? See, set is gonna be in our next video, but if you think set as like a collection and nothing else, it's like a collection. That's it. It's all is just a collection. Okay, so X person is an Indian. So now this can be applied to a collection, group, set of persons to determine whether they are Indian or not. It kind of tells that this person from this particular group of people or collection is an Indian. Quantifier. Okay, so you have created a collections. You kind of have like, what you see, it's kind of mapping. If I'm being like really if I put it in a really good words, it's like predicates are like a mapping. Okay, we are mapping some sort of features to a particular element. That's it. So we have taken out a person, and what we are mapping is an Indian. We kind of mapping it with Indian database, so we kind of link with him. We'll see this when function, when we're gonna touch function, we're gonna see that qualifiers are like symbols used to express. So since, hey, look, you have created a collection. Okay, you actually have created a collection, and now what are you gonna do? You actually have created a collection, and you're not gonna sit around and gonna count everything. You're not gonna do that. I mean, we're doing maths, we're not doing language. We're gonna time pass our thing. So we're gonna not gonna count out. We also wanted to know, like, really quickly, we're gonna represent it. We don't want to write also in maths. We always deal with variables and operators and all this thing. So they kind of have created just operators, and these operators are, like, for example, if each and every element of that collection is uh, representing, or kind of are being able to map to a particular property. So we're gonna represent it with for all. If at least one, it could be two, three, or four, but at least one is there, then we're gonna use their exist. Okay, that's it. That's it. It's not that useful, and but like we're just only looking at the useful part, and we're just kind of touching it up, so that our neurons could get recreated. They kind of reactivated whatever we have forgotten. If you haven't watched these things ever in your life, just to go through this. And if you want to study more, like, you can study more by yourself. Like, that's the very good approach to start with. Rule of inference. So what are these things, man? You're gonna ask, like, what are these things? These are nothing. Like, again, since they were able, they just wanted to create complexities, and like these mathematicians, these ancient mathematicians, these early mathematicians just want to create more and more complexities. So the very same kind of operators which we have seen behind, it's just, that's it. That's all these are. Like, they have just named in this way. So it kind of seems like, oh man, what? So they see, modest one is nothing but P implies Q. We saw that. Okay, we just saw that just a little bit back. Conditional statement. Modest tolerance is nothing but also P implies Q, but if Q is false, then P is also false. The dependency went a little bit back. So it's kind of like a negation kind of thing is here happening. Hypothetical silog is mm, hypothetical silog. It's like a hypothetically dependency coming up on the next premise or your proposition. That's what it is happening here. So you can think of, like, hey, I have, like, what could be the example? So if I let's take the very example P implies Q. If I get good grades, then I'll buy myself a treat. If I get good grades, then I'll be happy. Okay, so the implies could be, if I get good grades, I'll be happy. That's like a hypothetical silog. That's it. These are like really simple, man. The dissective silog, dissecting, I think you got the sense, like, it's like OR operator kind of thing. So here it's nothing but it's a combination of P, OR operator, down arrow, and Q is true, and you're ending with P is false, then Q is true. Okay, so only Q is gonna be remain, because you're gonna cancel out P. If like, have a bet with your friend, like, I'm gonna pay you $10 if this happen, or you're gonna pay me $10, but you didn't pay $10, so that means definitely your friend has paid you $10. Okay. Constructed dilemma is a little confusing, but it's not that confusing. It's as simple as that. If you look at P implies Q and R implies S, that means P and R both are true. If P and R both are true, if both of them are true at the very first place, then Q and S are also true. The example could be like, if I study hard, then I'll top the exam, and if I pass this semester, I'll be happy. It's like one example. So if I study hard and if I pass the semester, I'll be both happy and I'll be topping the semester. Okay, it's kind of like that, simple. Now, see, our logics are done. I think the more important part was logics, but like, let's also look at proofs, because like these are also the part. Since we have created our theories, we have, kind of conceptualize our problem statements, we kind of created complexities. Now it's time to prove. I mean, you cannot just live by your theories and like propositions, you also want to prove them. So there are some few methods to establish the validity of those problem statements of those complex, propositions. Is a direct proof. Direct proof is like simple, like, yeah, 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 see, direct proof, simple. You don't have to, get into like much of a detail. It's like they so example, like if you have completed your homework, you just show it to your teacher. That's it. That's a direct proof, because you showing it like directly, no, there's nothing else going on. And then there is proof by contradiction. And proof by contradiction is like you kind of contradict yourself at the very first thing. So for example, if yeah, that's a good one. So here, I don't know what happens in the outside colleges, but here in India, like a lot of private colleges have attendance system, and students kind of try to make proxies for those attendances. So I'm not gonna name. So my faculty was there, my lecturer, my professor. We gotta, like, he gotta take the attendance and go back again in his room and kind of counts the head. So if there is any sort of proxy, he get it like quickly, right, really quickly, who's not there. So it's kind of like that. So maybe you just went to your late class. I mean, you arrived your class kind of late and you denied that you weren't late, but the teacher presented kind of evidences. So then later on, what do? You now here gonna what are you gonna do? You already told that you weren't late, but your teacher has said that you were late. So you're gonna contradict yourself. You're gonna contradict here by providing some sort of explanation, or maybe some sort of a proof that what happened. So that's why you were late, so that they can grant you attendance. That's it. That's what the proof of contradiction is. Proof by contradiction. Then there is induction thing. Induction is like, if you have proof for one integer, the next integer is gonna be true. So we're gonna see a little later what that exactly is. But like example could be like, if it start improving grades in one course, your overall grades in semester can improve. So the dependency also went on to other integers or numeric values. Proof by case is simple. I mean, as you can see the word, that proof by case means that converting, you're dissecting the entire statements into really small chunks, and then what you're doing is that you kind of proving it by step. The example could be like a final year project that we used to had in our colleges, where we have to submit a final year, like a big major project. But what happens that after every 2 or 3 months, we kind of split it into chunks, so that we can also show what's our growth, where it went, what is happening. It's kind of, so that's what prove by cases. We kind of converted that into cases. Prove by counter example. Hmm. Oh god. Prove by counter example be gonna be, so for example, if you deny that you didn't study for a test, but you can prove by a counter example, if you have answered a question correctly, kind of thing. Counter example, you give providing a really opposite example. You said you didn't study, but somewhere you just answered the question. That's like, wait, okay. Contrapositive. Ah, contrapositive. God, like, no, I'm gonna provide last two examples on my blog, or maybe in the book. Go and read over there. I'm not gonna give you right here, like, no. I want to encourage you to read, study, and make your own notes. Like, this is very important, man. And I would highly encourage you guys to uh read and have your own notes. Just don't go by that. So I'm gonna put these examples over there. I'm not gonna give you right here, so that you just don't go from here and just skip to next video. Like, no. go and like read. Like there's a reason why I'm doing this. Like there's a reason why I'm like going this way instead of just uh practicing and just getting a quick job. I was like, hey, let's, if it can help someone, like gonna make me happy. So that's all I'm doing. So it doesn't even have anything to do although like uh, I have to do like really quickly, but that's what it is. Okay, so let's now look. You're gonna read it. You have to read it. I'm not gonna give you anything. Like, nah, nada. So let's go to the end part, and we'll see you in the next video. Okay, guys. Bye.